Why is ocean exploration so difficult? Why is ocean exploration so difficult? Why is the technology still not able to explore all the oceans? Why is that it's so important to explore the mighty oceans? Why is 95% of the ocean unexplored, even though the ocean covers more than 71% of the Earth, while more than 90% of the ocean is the planet's water? This is Why Is, and today we explore why ocean exploration is so difficult. Open your eyes and enter the world of science, curiosity, answers. Welcome to Why Is. Why is ocean exploration important? We know next to nothing about our oceans, despite the fact that the ocean plays a major role in almost everything we breathe, from the oxygen to the everyday weather cycles and changes in climate. Moreover, it won't be an exaggeration to say that almost all that we know and can know about the oceans lies deep down in the shallow water. Deeper oceans remain a secret, although we are progressively reliant on the oceans for food, electricity, and other commodities. Ocean discovery is really about gaining knowledge, hunting for new and unforeseen things, and life in the oceans. It is systematic and coordinated, with detailed analyses and documenting of the ocean's ecological, environmental, physical, geographical, and historical dimensions. Ocean exploration discoveries are important for rising variables in ocean floors and provide high-value, scientific information required to resolve existing and evolving research and planning concerns. Exploration means ensuring that ocean reserves are not only maintained, but are well maintained, so that upcoming generations will experience certain resources too. By ocean exploration, we may develop the basic info required to effectively comprehend the changes in the environment, minimizing downtime in the unexpected to produce dependable and scholarly evolution that is fundamental to delivering forethought about future circumstances and informing the choices we face on this diverse globe daily. Accessing deep sea environment secrets can introduce new routes of pharmaceutical medicines, nutrition, mineral wealth, and much more. Deep ocean discovery data helps forecast tsunamis and allows us to understand how shifts in the Earth's climate impact and influence humanity. There have been 2,000 plus tsunami events in the world, and millions of people have died in tsunamis. Exploring the ocean will promote underwater awareness and encourage youth to seek jobs in research, engineering, and ocean sciences. The complexities of navigating the oceans may provide the foundation for advances in technology and engineering that can be implemented in other cases. Even though the usefulness of oceans in our people's everyday lives continues to expand, our understanding of these fields continues to remain restricted. In many ways, we're flying blind when it comes to administrators, regulation, and commodity use in deep water regions. Why is ocean exploration so limited, even though we know its importance? There are many challenges that are making ocean exploration difficult. There are 4 factors that have kept us behind when it comes to ocean exploration: the absence of visibility, funding, buoyancy, and water pressure. Even when it's only a few meters down, you can see the bottom of the sea. It becomes gradually further and further challenging as the distance rises until it becomes dark. In this case, the most top-notch flashlights also turn to be useless. Very powerful lights are needed on submersibles that function at significant depths to see even a few meters. Did you know that it would take us 80 trillion years if we were to explore the oceans? Let's calculate how. The total water amount in the ocean is around 1.3 billion cubic kilometers. That functions at a flow rate of 43,200 liters per day, more than 15 million liters annually, which is about the capacity of a huge pool. The next move is to measure the ocean volume in liters by the pace at which the water flows down the hole, in liters per day. That provides us a final idea of more than 80 trillion years. And to put it differently, the whole universe has been in creation nearly 6,000 times lesser. You must have ships or autonomous submersibles to reach deep ocean settings, and some of these, in effect, must be able to endure the unspeakable forces that are being applied as you go further underwater. Now, many scientists use mini-subs, which are messy, pricey devices. The subs are also belonging to a business from which the vessels are leased by scientists. Renting a few of those crazy expensive equipment for a day will cost about $15,000. It's not like owning a lakeside speedboat. We aren't really made to operate at the highest depths. Certainly, perhaps not for long, however fine as modern mini-subs are. The sheer size of the oceans is yet another major obstacle. Note, oceans occupy about 71% of the surface of the Earth. And, with their hills, valleys, and plains, they comprise far more floor space than the mixture of all 7 continents. So you have a small number of people at extraordinary levels using a small number of very expensive equipment and under hundreds of pounds of pressure per square inch to discover 71% of the planet's surface. This is what causes it to be so challenging. Buoyancy is a very common issue for anyone who's been swimming. Buoyancy, or upthrust, is an upward force generated by water that parallels the weight of an entity submerged. In a section of fluid, because of the weight of the crustal fluid, pressure increases with depth. Hence, the pressure at the edge of a fluid column is higher than at the top of the column. A lot of us are big fans of floating in seawater, and hence, the same would happen with the weapon the teams will use. Definitely the submersible will float, unless you add immense weights to it. But ascent and descent must be carried out at regulated speed. All that pressure can cause the submersible to compress, and it extends once again when the pressure is missing. The problem certainly affects the layout, as it must be able to modify and extend without jumping a flood, which ensures the race wins nice and slow, and that it can significantly increase the mission's duration, since additional days need to be applied to it to take into account the slow descent and ascent. The last problem is obvious for someone who's been doing springboard diving or scuba diving. The further you get under the oceans, the stronger the water pressure is that is driving you under. The intensity rises by 14.5 psi, 1 bar for every 33 feet, 10.06 meters you go down, which ensures for the most part, the stress at the bottom of the ocean is enormous. The ocean is mostly very deep, between 4,000 and 5,500 meters. It's almost 11,000 meters to the surface at the lowest point, Challenger deep. If Mount Everest fell in, it would be way down, not up. The pressure beneath the water is one barrier to ocean exploration. To explore the ocean depths effectively, the enormous water pressure needs to be addressed to hold electrical instruments in service. In fact, the mechanical equipment would need waterproofing as well. The farther you go into the water, the colder it will become. A large majority of the world is completely dark and does not absorb sunlight. Researchers were already reaching into space in the early 1500s, but nobody could reach much further than a few tens of feet deep into the water, because quite lately, a significant amount of the necessary equipment to study the oceans has been developed. Deep sea research has not been founded like other fields of science. The deep sea and technological problems that come with it have made discovering the oceans challenging due to the extremely strange environment. To sum up, the equipment needed to conduct the discovery is very difficult to construct, and therefore very expensive to construct. Once the heavy machine gets down there, it cannot see much. Hence, it allows us finding out very little, while it may cost a large sum of money. It's really important to work, but we can only get limited success with limited resources. The next time the question arises that why is the ocean exploration so difficult, to forget that it's difficult because there's no light as you go deeper and the ocean becomes pitch black. The pressures are very high, which makes it impossible for the discovery to take place, especially in the current days. The ocean is vast, and it would take 80 trillion years to explore it all with limited advances in ocean sciences, and even lesser funding. And lastly, the buoyancy is unbelievable. The oceans are fascinating, and the deeper you go, the more unbelievable it becomes. But the question is, will we be able to go deeper to find out what we now predict as unbelievable?